Hello friends, how are you? And welcome to Unacademy, which is the largest online education platform for GATE Computer Science and IT. Myself, Mallesham, Devasane, and today in this session, I'll be discussing the most important topic, which is the evaluation of SDT. Guys, just give me a second. Yeah. Let's begin the session today. Our topic is evaluation of SDTs. In the previous session, we have seen what is SDT. And yes, good evening, Sanjeev. Good evening, Satyajit. Yeah, good evening. Sorry for late. There was a problem in uploading. Now let's move to the introduction part. And let me introduce myself before starting our session. Myself, Mallesham Devasane, have secured all day rank 119 and 210 in my BTech third year and final year, and then I have completed my MTech from IIT Bombay and completely have focused in taking the GATE classes after completion of MTech. Now today I'm taking TOC compiler programming on this channel. So here I have a referral code DEVALIVE to get 10% discount on Unacademy, and also this is going to help you to crack the GATE exam with the full support of me. Yeah. So what are the benefits of taking the Plus and Iconic subscription, guys? You will have the live classes from every educator. Once you come to the Unacademy, there is no limitation and which subject, which educator you are going to attend on live. That is your choice. So take the subscription as per your comfortability, either 1 month or 3 months, 1 year, 2 years. We always recommend to go for 1 or 2 years to get the benefits from us. Yeah, Sai Sandeep, good evening. And what are the other benefits? You have weekly tests, doubt solving sessions, and so many. And Iconic is more advantages than Plus, like you will have separate booster sessions and separate study material, and you will have a one-to-one guidance from the coach, and you will have a personal live interaction with every educator. And that are the benefits of Iconic. If you look at the classes that I have taken on Unacademy so far, which are completely free, and only one thing, you must visit my profile unacademy.com/devagatec and choose the special classes within my profile. On my profile, you will see them, and you have so many kinds of classes like quizzes and regular classes and revision classes, practice classes and guidance classes, and daily practice problems and previous year question series. And these are the various benefits of my classes on Unacademy. So please visit unacademy.com/devagatec. And you will have paid courses which are called as the Plus or Iconic courses, like next level TOC, next level course, that is a complete course on TOC, and practice course on TOC like C programming and compiler design. And similarly, soon I'm going to start again TOC. And what about other subjects? We have other educators in our team, and they are going to take other subjects too. And sometimes on same subject you will see multiple educators at Unacademy. That's a more beneficial for you when you have the time. Yeah. So what are the differences that I told about Plus and Iconic? These are the common benefits for the both Plus and Iconic. These are the only benefits for the Iconic people. So if you are going to take the subscription, look at the prices that you have. I'm talking about a Plus, 1 year, 1.5 year, 2 years, and do not forget to use the DEVALIVE referral code. And if you don't want any discount, if you don't want any support, then directly you can go for by paying actual amount. This is after discount. You have for 1 year 27,225, for 2 years 39,600, for 1.5 year you have 34,650. Similarly, you have Iconic subscription for 1 year, 2 year, which are very popular, and use the code DEVALIVE, and total amount you see that 40,500 and 54,000 for 1 year, 2 year respectively. And on this channel you have so many good educators, and please attend all these sessions from us, guys, and we are here to help you all the time. And let's begin today's session, compiler design, in which we have syntax directed translation. Okay. In the previous session, what we have seen is lexical analysis, syntax analysis, and also we have seen basics of SDT. Recently, that is in the previous class, we have seen what do you mean by attribute, and what is the attribute grammar, where attributes are associated with the symbols in each production, And you have seen translation scheme. It means we will place the semantic rules within the production, then we call that as a translation scheme, also called as SDT. And in attribute grammar we have two definitions, we call them as SDD, syntax directed definitions, also called as SDD. We have L attributed grammar and S attributed grammar. We have seen in the previous session. Just I am reminding you what we have learned in the previous session, and what is L attributed definition, what is S attributed definition, and basically this is about knowing the specifications of given SDT, right? Now today in this session we are going to look at evaluations of SDT, and really this is going to be a very interesting factor because there is no textbook that will talk clearly how many evaluations are there for SDT. So that is the reason you have to understand how many ways you can evaluate the given SDT. So the first thing is you have two kinds of SDTs. Okay, let me talk about that soon. Yeah. Okay guys, please like the session if you are watching this video, and it's going to help us. It's going to help us to understand. Yeah. And how many types of SDTs are there? If you look at, I'll talk about this evaluation techniques in this class. Do not worry about what is depth first traversal from left to right, and what is LMD, what is RMD, what is the reverse of them. And in general, in the world, we don't know how many evaluations exactly we can do for SDT. So, but based on our observations in the world, we are trying to find out some of the evaluations. And here two kinds of evaluations we are going to talk about. When you have attributes, you can always use L attributed concept, but grammar definition was L attributed and S attributed, right? SDT without attributes, there is no restriction in the world which evaluation order you are going to follow. So here we have two kinds of SDTs, with attributes, without attributes. When you have with attributes, you can follow your definition, but always this is enough. L attributed definition is going to use depth first traversal and also uses from left to right. I will tell you how to do that, but don't worry, named right now evaluation technique, don't worry about it. So with attributes, two concepts, and in that too, L attributed, S attributed, you can always use L attributed because every S attributed is also L attributed. S attributed actually follows bottom up parsing concept, because you need to depend on what children, right, synthesized attributes you will have in that grammar. So you can use always bottom-up evaluation. Bottom-up evaluation. So attributes are evaluated based on bottom-up evaluation. So if you look at the every S attributed is L attributed. Every S attributed is L attributed. So no need to follow S attributed any time for attributed grammars. You can always use L attributed technique to evaluate. We can always depend on L attributed evaluation if it is attributed grammar. If SDT is having attributes, SDT is having attributes in every semantic rule, every rule, you can say that. So this is how we can remember what we have for the attributes. When you don't have attributes, guys, really, I have not seen even single textbook that can cover all kind of evaluation techniques when you don't have attributes, because that purely depends on the actions that you specify. We'll look at it. The first one, when you have attributes, look at that now. The grammar is attributed grammar. Yes or no? This is attributed grammar. When the grammar is attributed, you can always use L attributed technique. But even though they ask bottom-up parsing, no need to go, because every S attributed grammar is L attributed. So you can always use L attributed concept that we draw the dependency graph. We'll follow depth first traversal from left to right. So whatever I'm going to explain, you can always follow for attributed grammar. In case it is not satisfying any definition, you can't evaluate. Like if it is not attributed, definitely you can't evaluate. Okay, yeah. Come on guys, keep liking this session, keep liking this session, everybody. Now let's move on to this. We have attributes. Now if I ask the question, is this grammar S attributed or L attributed? Come on guys, quick. Is it L attributed or S attributed? Yeah, please. L attributed or S attributed? Now look at, okay, here the numbering is missing, but in the exam they will clearly give numbering. So S1, S2. So just assume it is S1, S2. Okay, next, even you have two things, look at that. They have numbered it now, A1, that's good. Okay, yeah. So now look at how do you, yeah. S1 depends on S2 means depends on child, and S depends on A, again depends on child, value depends on child, A depends on A1 and B child, B depends on no one, it's okay, and A depends on B depends on ID. So here grammar is S attributed. It is S attributed grammar. S attributed grammar. Remember that. So you can always say L attributed. Even sometimes grammar is not S attributed, it is possible to be L attributed, because L attributed can also depend on parent or sibling, right? So that is parent or left sibling. That is the additional feature of L attributed, and the translation can be anywhere in the production for L attributed, right? S attributed, the translation position is fixed, and what kind of attribute, that is synthesized attributes, can only be used in S attributed grammar. Okay, now this grammar is S attributed. Whether they ask S attribute bottom-up parsing or not, we don't care. We can follow our own technique, dependency graph technique. Then what is it? They will give you input and they will ask. It's not output, guys. It is attribute value computed at the root. This is called as a translation. This is called as translation of an input. It's a purely depends on what value you compute at the root. What value you compute at the root. Is it clear? Because when we draw the tree, you will understand what I'm trying to speak. Okay, now I'm going to draw a tree for this ID plus ID star ID. And if you know about it parse tree, first I'll help you how the parse tree looks like. Okay, multiplication, and then we need addition. Addition, you should go to the left side. So I will go to A and I will go to A plus E. Then my target is to get ID. So A to B and B to ID and E to, this is sorry, B. It's a B. A, this is a B. Okay, B to directly ID and A to B and B to ID. So did you get that ID plus ID star ID, guys? Is that clear? And now we want to evaluate. So they might give instead of ID plus ID star ID, they will give you something like 2 plus 3 star 5, so that you can compute the value. Directly you can't do, right? This ID plus ID star ID, you don't know what is the meaning of it. So they will give you some integer values to understand, or some real values also possible, depends on the types. So some values will be given to you. So I'm taking 2 plus 3 star 5, then how this is evaluated. For that, I am focusing clearly, guys. This parse tree, but we are going to draw annotated parse tree. This annotated parse tree will have all the semantic rules inside the tree. So parse tree along with semantic rules is called as annotated parse tree, guys. What is annotated parse tree? Annotated parse tree, or you can say decorated. You may call it as decorated, or you may call it as semantic if you are using the semantic analysis. So what is this? It's just like a parse tree, no doubt. Whoever good at constructing parse tree, they can easily do it. Plus, along with you have semantic rules. Yes, exactly. Now let's move on to this. Now I'm trying to construct the tree, guys. Help me, and by place you need to place exactly wherever the translation is there. Yes, star and A, and you have a translation here, so you must have the same translation like this, S dot value, that is a one, you remember, S dot value. No need to write in the exam, guys, no need to write in the exam. Okay, now we have, you can number the translations, you can do that. Now we have S derives A. What A is doing, this translation is going to tell you, okay, S dot value is equal to A dot value, right? So I need space definitely, so I just need some gap here. S dot value, even you can write A simply, A dot value, and A, I just want to do A plus B, and you know the rule, so I'm just keeping 3 dots to understand what should be done there, to know, to avoid the more space here. And A, I want B, and you know, just it is assignment, you can number it and you can write it ID, and there is B dot value is equal ID dot value. And similarly you have for B to ID, and there is a rule for this. Okay, keep doing that. A, you just do it, B, and there is, you can write that if you want, A dot value is equal B dot value, ID, and you have something here. Yeah, we don't speak output of the input, we speak here what is the attribute value computed at the root. Come on Sanjeev, it's not the output of SDT, it is what is the attribute value computed at the root. It is called as a translation. Output we speak for the grammar which has no attributes. Anyhow, there is no output word now, that we will see slowly. Come on, we are only learning first what is the L attributed grammar evaluation, guys. We are only understanding what is the L attributed grammar evaluation. If you keep on moving, you have S attributed grammar evaluation. Now when it comes here, look at the word output comes, then why are you worried about the future topic? पहले तो समझ लेना जो बता रहा हूँ, राइट? तो आपको पहले L attributed टेक्निक चाहिए, राइट? आपको ऑलरेडी सब्जेक्ट आता है तो जाके पढ़ लेना, देखना जरूरत नहीं क्लासेस. ऑलराइट, everybody clear? What is the L attributed evaluation? So I'm going to draw a dependency graph. That dependency graph is actually depends on depth first traversal from left to right. Okay, now we have decided 2, 3, 5. This is the 2. Guys, look at that. This ID is the 2, and this ID is the 3, and this ID is the 5. We have already fixed the values. Clear? And now we want to do 2 plus 3 star 5. We have a tree, and guys, if the grammar is ambiguous, definitely we don't consider. Multiple computations are possible. So now we are going to compute some value at the root. That value we need. For that purpose, guys, look at what I am going to do. Actually, I need more space in the root. I need actually more space in the root. So I will write a B, and I am keeping the space to keep some value all the time. So this kind of problems, you need to give a space so they will not confuse what you are doing here. Right? Everything we will maintain in the node only. So I'm just keeping for you having a clarity. What I'm going to do is I'm going to keep a bigger circle to specify. I'm going to assign some value there all the time, so that I'm redrawing it just to have a clarity. Yes, this is gonna happen. Right? Initially you will not understand, do you really require or not. Now I understood, yes, I require some value because we are doing first time. So definitely you need some space there inside the root, because we will compute the value at the root all the time. Okay, now we got something. Now what is this L attributed evaluation, guys? L attributed evaluation, you just traverse depth first, and that is also from left to right. And from here, just a scan left to right. But how is that possible? Left to right. Left to right, I am saying it, but left to right is not just left to right. So we have to use two things, bottom up and top down. Two concepts are going to happen here, bottom up and top down. The mixed concept, because of you have the synthesized attributes you may have and inherited attributes. Inherited attributes are evaluated using top down parsing, top down evaluation, and the synthesized attributes are considered as the bottom up evaluation. Now in this process, one thing is going to happen. You need to number the translations order, because we are going to look at the translations here. This depth first traversal will help you translations order. Translations order. And in this class, in this LAttribute evaluation, we are trying to find which translation should be evaluated first. Is that clear? Which translation should be computed first. So I'm trying to help you one thing. That is, this first one is purely depends on translations order. It's not going to depend on non-terminals, but the remaining all depends on non-terminals order. So ये दोनों आपको याद रखना ही पड़ेगा कि आपको कहाँ देखना है, ये देखना पड़ेगा आपको. ट्रांसलेशंस को देख रहा है, नॉन टर्मिनल को देख रहा है, तो दोनों में फर्क है guys. So this L-attributed evaluation, depth first traversal from left to right, we always look at a translation. Is that clear? So let's move on. Now which translation, if I am going to scan, actually in order concept, exactly the same way we do it. So this considered as the first. Guys, this is the 1 and this is the 2 and this is the 3 and 4, 5th, 6th, 7th. How do you know that is 6th, 7th, 8th? Because actually when you bring down guys, that's going to be the first and second and third. Look at that. This is going to be your order. Guys, look at the numbering what I'm doing. So it's a depth first and follow from left to right, but look at all the translations from left to right. Everybody, so it can also do topological order. This is called as actually topological order. Everybody, now I'm going to compute some value at the root every time I do. First, the order we have decided, guys. Order we have decided. Okay, I need to understand what is this 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to evaluate 8 semantic rules. First one, I'm doing first one. Tell me what is the first one? B to ID production. This production, guys. This translation. Okay, ID dot value that I'm going to keep in the root. So B dot value is a 2. Look at that. That is what attribute value. It's going to keep the 2 inside the root. That's how the attribute computation happens. The first is over. Then second. First is over. Second. The second is the A to B. This production. The B value I'm going to keep in A. That is equal to 2. And second is over. Third. Look at the third. Third is B to ID. Again. B dot value is equal to ID dot value. That is equal to 3. And fourth. Next is the fourth, guys. Fourth. What is the fourth? That A to A plus B. This is the fourth. Remember, how do you know that? People confuses a lot what is the kind of translation. Guys, when some production is there, X to X, whatever it is. Whenever alpha, beta, some rule is there, guys, this means it belongs to this production. Remember that. When you have something, wherever, doesn't matter, it is even alpha, beta, this belongs to X to alpha beta production. Remember that. And you must remember what production you are looking at. If you don't understand which production, you will confuse with a lot of other productions too. So you must have a clarity which production you are looking at. Everybody, if you are watching this video, please like the session, guys. And you must look at clearly which portion you are looking at. This production, guys. Every time let me delete the previous one. Now the 4 nothing but this is the fourth rule, guys. It's not A plus B, it is A minus B. If you are underestimating your production, you are wrong, guys. Your production may be A plus B, but actually you might be doing minus. So you must look at minus only. You must understand it's not a plus. The internal meaning is the minus. Sometimes multiplication, sometimes division. This is the syntax and this is the semantic of that plus. But for outside the world, plus might be addition, but internal to the compiler and programming, the plus could be subtraction, because I'm hiding the meaning of the actual logic. Okay guys, that is very important. Now I'm doing a subtraction. 2 minus 3, guys, it is going to be minus 1. 2 plus 3, please don't do as a 5, it is a minus 1. It is minus 1. Everybody, it is minus 1. Clear? Next, fifth one. Fourth is over. Fourth is over. Third is over, right? This is a third, sorry. I third or fourth? Third or fourth? Third, did I do the mistake? Third is over. Fourth is over. Come on guys. Yeah, fourth is over. Now fifth. Fifth, guys. Quick. What is this fifth? S dot value is equal to A dot value. Now keep on numbering it and remember them what you are doing. This is the fifth. And A value will go to the S, that is equal to minus 1. Right? Exactly. Keep focusing on how much you have done. That's why numbering is very important for us. Next, sixth. Sixth job is, fifth is over, sixth job is. Now look at what is the sixth in your production. The S B to ID, that is this production. That ID dot value is going to assign to B, that is equal to 5. And next sixth. Next sixth is over. Yeah, next seventh. Seventh is, look at A to B production, this one. B is going to assign to A, that's equal to 5. And that's over. Now eighth, numbering. Last one, guys. That A dot value is a minus 1. And minus 1 into 5. Is it into or plus? You have to look at inside. Minus 1 multiplied with 5 is a minus 5. So that we will get a minus 5 at the end. So that's what this final answer. Everybody? Clear this point? Minus 5. So the value that is computed at the root is minus 5. Don't say it is output. Of course you can answer it. But it is the attribute value computed at the root. Computed at root. Finally. But for that, I'm using the one technique. Go depth to left and scan from left to right. Gather all the translations in the order from left to right. So I'm trying to tell you guys, if there is a tree, something like that, what do? You go left and scan left to right. But in that process, you might scan like this. That's how you get it. Everybody? This is how you get it. Yeah, it's a depth first traversal. Depth first traversal. But we are looking at translations only. Traversal is depth first, but evaluation from left to right. Remember that the people do not misunderstand the concept. You will traverse like depth first. Traverse like depth first. And evaluation from left to right. Evaluation of translations from left to right. Two things are there in that traversal. Okay, you traverse like depth first, but do evaluation from left to right. Yes. Now I hope you understood. Answer is minus 5. Now there is another question for you. Same question, but they are asking evaluation using a bottom-up parsing. Evaluation using bottom-up parsing. Guys, bottom-up evaluation or bottom-up parsing. Bottom-up evaluation purely depends on RMD in reverse. In sometimes they may ask LR parsing or SR parsing. All parsings are same, guys. They use the RMD in reverse. So in the exam, you do not know what do they ask. But finally, you go for just a top L-attributed evaluation technique, because every S-attributed grammar is L-attributed. So I can also use the L-attribute evaluation. The answer will be same. No need to follow reverse of RMD, guys. You can follow again. You can follow. It is attributed grammar. It is attributed grammar. So if it is not attributed, you should be careful. It is attributed grammar. So instead of RMD in reverse, you can also use the depth first. You will get the same answer. We get same answer. But I am proving it now. I'm going to prove it now, guys. I'm going to prove it now. You can use. Now, what is this bottom-up parsing RMD in reverse? Let's look at. This is going to depend on non-terminals order. It's not going to depend on translations order. Non-terminals order. That which non-terminal is going to be reduced first. And for that, you should know first what is RMD, then you should do the reverse of RMD. So for that, I'm trying to help you what is RMD, what is reverse of RMD. So let's consider the tree. Let's consider the tree as usual, guys. Now you don't need to attach the translations. You don't need to attach the translations. Look at that. S star A. And please remember, this is S. You can assume S1, S2, and similarly you assume S1, S2. The order is very important. And then S. Here I am not going to use annotated tree. Annotated tree now I don't care. The reason is I depend on non-terminal. So non-terminal decide when to use the translation. Now A plus B is over, then A2 derives B, B derives ID, and same, guys. Is it over? Yeah. Now you need to number the non-terminals. If it is RMD, guys, if it is RMD, you know that first you take S, then S star A, then the rightmost non-terminal, that is S star B, then rightmost again S star ID, and so on. You know that. Next S is A plus B. This is RMD, right? This is RMD, right? Come on. A star B, then B is going to be rightmost. So A plus ID star ID, then finally B plus ID star ID, then finally you get ID plus ID star ID. Okay, that's RMD. Its reverse gonna become the reverse of RMD. We want this direction. So if you number the first one, then other is easy. So I will number this first. This S is exactly same as this one. Yes or no? Yes or no? And next, this A, you should look at which A. There are so many A's in the past tree. This A is that. And this B is the next in RMD. So this will be 3. I am numbering RMD. So guys, RMD numbering is important first, because we are doing theoretically manually. Okay, next B2 ID is over. Next, this S, you need to find out where is that S. This is going to be the fourth one. And next, this B, and so many B's, you should know which B you are talking about. And next, this A is substituted, so this is going to be 6. And next, this B is going to be 7. And that numbering is very, very important, because RMD numbering is going to answer everything now. Okay guys, you should be good at numbering. If you don't number well, then obviously this method is not for you. Okay, total 7, yes. Now reverse I want. Guys, reverse तो मतलब आपको समझ में आना चाहिए reverse of RMD क्या होगा. अभी हम reverse करेंगे, बस 7 से start करेंगे. 7 के बाद 6, 6 के बाद 5, 5 के बाद 4, 4 के बाद 3 होगा, 3 के बाद 2 होगा, 2 के बाद 1 होगा. बस आप इस सीक्वेंस में आपको नॉन टर्मिनल को एवेल्युएट करना है. तो नाउ लेट्स बिगिन. Who is the 7th translation, 7th non-terminal? That is 7th means this one, guys. There's B2 ID production. This production is the 7th production. So ID dot value you are going to place. You are going to place inside the B. First, let's number it, guys. You are assuming, right? 2 plus 3 star 5. Then I'm assuming first this is 2, this is 3 and 5. And what is 2? It's going to be assigned here. Clear that point? That's after execution of the 7th. 7th is over. Next 6. What is the 6th concept? Where is that? Where is the 6th? Guys, look at that number. 6th is this one. 6th is that one. That means A to B production. A to B. This production is the 6th. Now B will be assigned to A. That's equal to 2. That's equal to 2, guys. If not clarity, make it clarity. That is equal to 2. B value is assigned to next 5th. Next 5th. We have to do next 5th. What is the 5th? Look at B to ID is the 5th. That is ID is assigned to B. That you will get equal to 3. Clear this point? Come on, come on, come on. Now 4th we have to do. That is the 4th we have to do. 4th means the S production. S production. Where is it? S derives A plus B. S derives A. Sorry guys. One small mistake I have done. For that reason, I have to do whole thing again. In the previous one, this S derives A is there. That I missed it now. Yes. Is anybody identified that? I was doing very quickly. So you require that portion. So I'll just little bit update it because I did the mistake. So I need to do that. You have S here and first you have A here. Then that A will have this one. So one extra number comes. One extra number that is going to be here. Directly I put A plus B because I didn't look at the grammar. Directly I was assuming myself. So A star ID first, then A plus B star ID. So in that process, you have after S A, after A B. So after S, just numbering it. Okay, 3, then this is the 4, then you have this is the 5, right? Then 6th, 7, just extra number comes, that's all, 8. So extra number I'm making it just to have a clarity. Sometimes it happens. So extra number I'm doing it, guys. So let me do it now. 8, 7, this all are over. Now I'm doing this. Which one? 6th one. First 6th one. So 3 is over. Then 5th. After then 5th, guys. Then 5th. So what is the 5th I'm doing now? Is A plus B. That is 2 plus 3. That is 2 minus 3 is going to be done. It's going to be equal to minus 1. Exactly what we have done. So equal to minus 1. So it's not looks proper. So again I need to do something here. So I'm just writing the root equal to minus 1. Now then after 5th, then do the 4th. 4th means just assignment. That is A dot value to S. Then 3rd. Then 3rd. 3rd is ID assigned to B. So 5 that is, and again assigned to, it's over. Then last one is the 5 into minus 1. It's going to be minus 5. Did you get the same answer at the end? Did you get the same answer at the end? Yes, you got the same answer. The reason is because the grammar is both L attributed and S attributed. Grammar is both L attributed and S attributed. And when the grammar is both L attributed and S attributed, the answer you can always depend on L attributed because both will give same answer. I'm writing the point. No need to do this kind of analysis in the exam, guys. When, okay, if attributed grammar, remember this point as a note. If attributed grammar, if it is not attributed, be careful. If attributed grammar is given and it is both L attributed and S attributed, we can always use depth first traversal to find attribute value at root. We can always use, no need to follow bottom-up parsing because depth first traversal and bottom-up parsing will give the same answer even though both approaches are different. Is it clear? This is the non-terminal order, guys. I have not looked at the translation order in this RMD in reverse. First I found which non-terminals in the RMD, then I just did the reverse. I just did the reverse of them. But I used to number them to understand what is the RMD numbering. Then don't do reverse of RMD numbering because it's reverse only RMD in reverse. Okay, guys. Come on. Okay, so now to understand the another approach, guys. Now this is translation scheme without attributes. Now can you see any attribute here? Print 1, print 2, print 3. Directly it's going to affect an output. Now I ask output. Now I don't ask what is the attribute value computed at the root. That is for attributed grammars. That is for attributed grammars. There I may use the output, right? Sometimes I can mix both of them, guys. I can produce the output, I can also compute at the root. Mixed combinations are also there in the world. Then you should be very, very careful, right? So that is important for you. Okay, now this translation scheme which have no attributes, right? So now I'm trying to tell you we have three kinds of SDTs. SDT with attributes and without attributes are there, that's fine, but which are going to give some result. They purely depends on print something at every time and do something, print or something or do something else. And there are other things with attribute. This with attribute, the value will compute it at the root. Attribute value mostly will compute at the root, will be computed at root purely based on attribute. But there could be mixed one. It's a with attributes and you might be printing something, print something also. It means both will happen here. We will compute attribute value at the root. This will happen at the same time and also produces some output. So three kinds of behaviors you will see in SDT, guys. So you must be look at what I'm doing actually in the given SDT. Are there only attributes? There is no kind of printing something or doing something. Because sometimes do something means constructing syntax tree. Do something means producing tree address code. Do something means producing the parse tree. I can do many things, guys. So you must be careful what you are trying to do with the given SDT. Okay. Now they are producing the output. I may be constructing the syntax tree sometimes. Then you will see the graph output as a graph, guys. Now let's see. And question 1, did they mention any order to follow? Not, right? Look at the grammar. All the translations are the end, right? So you might assume bottom-up parsing you can follow, or you can follow the depth first traversal. Both will produce the same output. It's like S attributed and L attributed grammar, because even though there are no attributes, all the translations at the end. So this grammar comes under both S attributed concept, L attributed concept. So now the question 1, question 2 and question 3 and then question 4 and also the reverse of RMD question 8 will give same answer now, because grammar looks like S attributed even though there is no attribute, but translations are at the end, and you can say L attributed because you can look at the translations, you can decide which kind of grammar it is even though there is no attribute. All the translations at the end which can come in both the kinds of definitions, guys. Now use this 5 problems, right? 1 2 3 4 8, all will give same answer. Do whatever, whether you follow depth first traversal, whether you follow bottom up parsing, answer will be same, and other 3 might be different. So we are going to do that, right? Yes, all translations at the end. By looking at that, I have concluded, okay, these principles, all translations are at end. This can happen in both grammars even though there is no attribute. This is not attributed grammar, but you can use any technique now, guys. Now first one, depth first traversal, guys. Now I am giving input. Already input is given here. AAB is my input. Input is AAB. So now please draw the annotated parse tree, because you want the depth first traversal, L attributed technique. L attributed grammars, they follow this technique, right? Topological order, you can say that. A, capital A, but do not forget to write the print 1, because that's going to be very important for you now. Print 1. Okay, next you have A, you need to derive S, B, there is a print 3. And then finally you require A, that is a print 2. Now what you have to do, you need to find out the translations order from left to right. You need to find translations order from left to right. That will be very easy in this technique once you consider the tree, and that is gonna be, you go left, depth left, yes, then you just traverse, very simple, just you traverse, and look at that, the 2 comes first, this 2 comes first, and this 3 comes next, and this 1 is going to be last. So output is, now you say what is the output, is the 2 3 1. 2 3 1 is an output for the given input AAP. Everybody, come on, this is gonna be easy. Previous 2 techniques you are computing the value, attribute value at the root, so you need to be going top to down and bottom to up. So this is going to be very difficult in the previous one because of attributes. Now there is no attributes, just bring all the translations down and look at left right, okay, but don't cross the lines. And 2 3 1. Now if I follow reverse of RMD, answer should be same 2 3 1, because the grammar is both, right? If the grammar is not both, then answers might be different. Okay, now LMD and reverse of RMD, very easy guys, very easy. Now look at, please don't write a translations now, not required. Why? You will see that you don't need a translations now, you can decide later on also. Just number them. What is the LMD numbering? You know LMD, yes, will substitute with AA, and AA will substitute, the capital A substitute with S, B, and then capital S you substitute with A, and just number them properly, and how do you number? This is the 1, and this is the 2, and this is the 3, and this numbering is called as LMD numbering. LMD order. What is LMD order? 1 2 3. And what is the reverse of LMD? It's reverse. Whatever you get the output, just do the reverse of LMD, not RMD guys, reverse of LMD. 3 2 1. No need to execute again, guys. Now tell me who is this is the first one, right? What is the translation correspond to that S? Because you look at this one, this is the 1, indirectly this is 1, everybody. So what is the corresponding one? Print 1. So 1 will be produced. Then second number is this one. So what is the correspond to this production? This is the 2 guys. 2 means that A to SB, that is the 3 is output. Next, the third S, that is this one, this is the third, means you should look at this production. S derives A, that is a print 2. So 1 3 2 is an output if you use LMD. If you use the reverse of LMD, then reverse is 2 3 1. This should produce 2 3 1. Don't execute again. So LMD produces 1 3 2, and reverse of LMD, that's just reverse of that output, 2 3 1. Yeah. We have eliminated. Who told you, Sandeep? We have not eliminated. That LMD was the parsing technique, not the semantic technique. That is a parsing technique. This is a different one. This is a semantic. How do you understand the meaning of the syntax is different? How do you derive? Have you understood the 2 words? How do you verify? Guys, those people who don't understand, how do you verify syntax of program? This is different. How do you verify meaning of your program? Both are different, yeah. Both need not be same. Meaning of program. Understood what I'm saying? This here syntax analysis that you can use top down bottom up. Here both are individual, both are different. If you have the top down parsing technique in the first one, second may have anything, right? This is verifying the syntax, this is verifying the meaning. Here SDTs we are using to verify the meaning, and of course I might use verifying the syntax. You don't know that, right? Verifying meaning is different, verifying syntax is different. It's internal to the syntax, right? Everybody, both are different. Here approach can be anything. Okay, don't assume that syntax analysis is same as this syntax. This is not syntax analysis. It depends on syntax, but it is doing semantic. In this semantic verification, I can take care of any kind of evaluation. That's what this many evaluations. Do you see that only LMD, RM? Did I talk about that? Look at that. Look at that. I can use bottom-up parsing. I can use so many techniques in the world. Bottom-up parsing, LAttribute evaluation, LMD, reverse of LMD. Have you studied that? There is no parser you have studied about reverse of LMD. And RMD reverse. These all are semantic techniques, guys. The semantic techniques could be any in the world. Okay, but some attributed grammars, they have specific evaluation techniques. Fine. Now come to the point. Come to the point where we are. Is that clear? LMD. Now let's move to RMD. Now input is same. Input AAB. Is that correct? Yeah. Now again, this also depends on non-terminal order. Like, let me do it very quickly. A, S, B, A. This is your tree. Tree is same everywhere. This tree is same everywhere, guys. You follow L-attributed concept, you follow S-attributed concept, you follow LMD, RMD, any technique in the world, this tree is same, right? But are you considering translations or not? That depends on the technique, right? Okay, now I'm numbering it. Can you number it? RMD, can you do it? So that reverse of RMD is become so easy. RMD order, guys. So I'm doing it. Yes, A. And now capital A we substitute with SB. Always you are getting one non-terminal, so it's same. It's very easy now. And this is the 1, 2, 3. So this is the 1 and 2 and 3. So we are going to number like 1, 2 and 3. Clear this point? And reverse will be its reverse. So what is the output produced by 1? Check that. That 1 means you must look at this one. This is the 1. That means you look at this production. That is output is 1. Output is 1. And 2. 2 means you look at this one. This is your production. Remember that. A production is SB. That is a 3. That is a 3. Come on, guys. And next. Yes. 3. This is your third production. That is S derives A, that is a 2. You need to produce after 2. This is 2. And RMD producing this output is 1, 3, 2. So reverse of RMD, just reverse. Don't do anything. Right? Reverse will be very easy. Don't scan again. Reverse of RMD is 2, 3, 1. Clear this point? Yeah, this is how we do evaluation. Now, guys. Okay, before concluding something, let me explain with one more homework question also there. And if anybody interested for the plus, please know about the plus benefits. You have live classes, you have crash courses, you have weekly tests, you have doubt solving sessions. And what we are teaching, you are seeing only what we teach actually. That is 20% of our actual content you are seeing on this YouTube channel, guys. But this 20% also looks very huge for you. The reason is you might not see the same content in other YouTube channels, in other places, in other institutes. So you don't believe that what is going to happen in the plus and iconic courses. And what we are bringing you is very limited. And we are teaching with a selection of the problems. And you will have, even though every concept, but you may not master because of not clarity in some of the concepts, because you don't have much practice in the concepts. So when you come to this plus and iconic, we will help you to understand every concept clearly in a sequence with more practice, right? With more quizzes, with more discussion, you will be mastering. That's what the benefits of plus and iconic, guys. So believe us, the plus and iconic are really beautiful and they will help you to crack the exam. And I recommend you to, if you are preparing seriously, don't waste your time here and there, and please join plus and iconic and prepare. Take 1 or 2 years subscription, prepare seriously, you will definitely get the rank. Okay, so we are there, and this is my profile to know about my classes. How do we teach more than this? And you will definitely understand there. So unacademy.com/devagateCSE. And look at this, guys, and find the attribute value computed the root, and input is given. And can you do that? They have not mentioned anything. Is this grammar L-attributed, S-attributed? You cross check first. You are computing here by depending on children, by depending on children, by depending on children, depending on children. Yes or no? Yes. So this is S-attributed grammar. How do you know that? Every attribute is synthesized, value is synthesized, and all translations at end. Assume that I have not given actually. So assume that. Okay. Assume that all the translations are at the end. If not at the end, you can't say it is S attributed grammar. Remember that. Okay, assume all the translations are at the end. So this grammar is S attributed, so L attributed. Now you can follow blindly the construct the parse tree and follow depth first traversal. Is it clear? So do it. And look at this question. This translation is not at the end, right? All translations are not at the end, right? Some translations are in between. So this is not going to follow S attributed. So nobody should ask, please, if anybody asks, is it S attributed? You should say not S attributed. But you can say it is L attributed even though there is no attribute inside. Because of the translations can be placed anywhere. Now when I am talking about this one, you can just follow the concept of L attributed. You can use depth first traversal concept because it's L attributed works. Now if anybody says that S attributed, please don't apply. But if anybody says bottom-up parsing, you can. This word and this word is same exactly. Even though grammar is not S attributed, you can still use bottom-up parsing. Use reverse of RMD concept because output only need to be produced, and LR parsing is exactly same as this one too, and top-down parsing and LMD both are same, guys. So you can use here 4 techniques, but don't use the name S attributed grammar. Here doesn't work S attributed word, but it works bottom-up parsing word, bottom-up evaluation word which works. So please find the output of this grammar with the help of now translation position is changed. So the question 1 and question 2 may produce a different output because when you are drawing this input is same, right? Input is AAB, input is AAB. So look at that, what's going to happen. Look at that, what's going to happen, guys. This time the translation positions are changed. So look at the output which is going to be different from the previous one, and S is going to be A and this is 2. Now when you are moving from left to right, the first output comes as 3, then second 2, then 1, 3 to 1. But previously when you look at the previous example, what was the output using a depth 2, 3, 1? Can you see that? If this is placed here, then look at the difference, guys. And this is placed here and the output order is also changed. Output order also, that was the 2, 3, 1. Now I'm trying to say that 3, 2, 1. Is that clear? I'm sorry, guys. I did some mistake here. Yeah, I'm sorry. The 1 is here this time. Okay, 1 is here. So exactly place in the same position. Place in the same position. 1 is here. So now output slightly changes because again output is order changed. 1 is here and go here and take left to right. So first output comes 1, then 3, then 2, and have a clarity in that. So now output is 1, 3, 2. So here the one point is, if translation, that is semantic rules position changed, then output of that SDT also may change. Where? In L attributed concept, that is depth first. But here that's first point. Second point, output will not affect for other techniques, guys. Output will be same for the same grammar. I'm talking about for the same grammar we are doing that. For the same grammar we are doing it. Remember, for the same grammar, don't change the grammar. Output will not affect the previously whatever the output you get now also. Output will not affect for LMD and RMD and reverse of LMD. All of them will have the same output because they depend on non-terminals. They don't depend on the translation position. How this is going to happen? Look at, guys. This comes first. Doesn't matter where is the translation. It may be here. It may be here. That is going to take. Right? Even you keep it. If S is the first time that I want to consider, I have to bring wherever it is. So it's not going to affect where do you keep the transsemantic rule. It's which non-terminal you consider first. It is important for LMD and RMD. It's reverses. So this is one of the important point. The L attributed grammar purely depends on That is, where do you place the semantic rule, because evaluation depends, the implementation depends on the position of the translation, position of the semantic rule. Clear this point? Okay, anyhow guys, so we are going to start. The next topic is going to be 3 address code, intermediate code generation, and in this class we have learned attributes. In the previous class itself we have learned, and definitions also we have learned. Today we have completed evaluation order of SDT with attributes, without attributes. In with attributes only we have two techniques, S attributed and L attributed. And whether the grammar is S attributed or L attributed doesn't matter. You can always follow L attributed. We can always do that. We can always do this. Right? Evaluation purpose. Without attributes doesn't matter. Any order can come in the exam. They don't ask, then follow L attributed by default. When they ask, follow them blindly. So don't introduce your own order. Whatever they ask in the exam, any order that depends on the question, that depends on the data, that depends on given question. So see the question and read carefully. When you don't have attributes, and look at, are they asking LMD or RMD, reverse of LMD, reverse of RMD, top down parsing follow LMD, and LR parsing follow reverse of RMD, SR parsing follow reverse of RMD. And when they don't mention, by default you can go for depth first traversal, that is L attributed evaluation kind of technique. Okay, so thank you so much guys today and tomorrow, and today anyhow 8:15 I'll come back to this TOC, theoretical theory of computation for closure properties. But tomorrow and day after tomorrow we have very interesting sessions, and 8 p.m. tomorrow we have how to prepare GATE from second or third year BTech from engineering onwards. We are going to target very beautifully, and please attend this session which will really help you. And 9:30 p.m. tomorrow, discuss your doubts. If you have anything related to the GATE, and you can discuss with me, I will try to post, I will bring some questions which you may have doubts, and you can also keep on posting your doubt, like sir, what textbook I need to prepare for pointers. You can ask any question in that, right? 9:30 p.m. you can catch me tomorrow, and 8 p.m. Day after tomorrow, last 2 months strategy for GATE exam. So which could be the best for the last 2 months strategy? And 9:30 p.m. day after tomorrow, tips to find your mistakes and correct them before the actual exam, because these mistakes you may repeat in the exam. So instead of realizing in the exam, realize before exam, so that you can minimize your mistakes in the exam. Okay, so these are the important sessions for you on coming days, and do not ignore these 4 sessions which are 30 to 45 minute session. So it might help you, or you can ask me more questions in that sessions. I will help you to resolve them. And thank you so much for today, and do not forget to follow my classes, unacademy.com/DevaGateCSE, and all classes are segregated in very well manner, devagatecse.com. So you can also visit that. So this is our GATE Computer Science group Telegram channel. Please subscribe this to get daily links, and these channels please share with your friends, because we are here to help you, to train you and to guide you and to take care of you in right direction. Thank you so much for attending this session, and please keep attending, and don't forget to like this session and do that, and which will help us to reach many students. And you are actually caring us, because you are attending every session and you are realizing what we are teaching to you, and you are also asking very good doubts. And thank you so much for attending every session, and like and comment if you are having any doubts, and tag us so that I will tag me so that you will reply as soon as possible. And thank you so much, and subscribe, don't forget.